mortgages is the topic of this video. A mortgage is a loan used to purchase a home, a parcel of land, or the physical building, that would be a business, in which the borrower and the lender agree that the lender, the bank, has the right to take the borrower's property. So in other words, the bank has the right to take your house if the money borrowed plus interest is not repaid. Working into or getting into a mortgage is not something to be taken lightly. Just as a little bit of kind of fun trivia on the side, the word mortgage actually is derived from a French term meaning death contract. Just a little piece of fun trivia for you there. So the mortgage formula is actually the exact same as our payout annuity formula, if you have been working on those questions at all. So it is the principal, the amount you are borrowing, times, I'm going to use a capital R to represent the regular monthly payment instead of a W, which represents a withdrawal, but it's the same formula. And then the rest of this will probably look familiar. 1 minus the quantity 1 plus R over N to the negative NT power, all divided by R over N. Again, R, N, and T representing all of the same quantities that we are used to them representing. Interest rate, number of payments made per year. So for a mortgage, typically that's going to be 12. It is usually not specified in a mortgage problem because the assumption is you are making monthly payments for your home or for your property. And then T is the time in years. You will use this mortgage formula when we are talking about a mortgage or a loan. Because a mortgage is a type of loan, and that you are making regular payments. Now, the other part is I don't want you to think that just because it says loan, it is a mortgage. There are such things as simple interest loans. And so if it does say you take out a simple interest loan, you need to use a simple interest formula, okay? But if it just says you take out a loan and, for this much money, whether that's a loan for schooling, whether it's a loan for a house, there are some car loans that also use this formula. So while it's called a mortgage formula, you might also see it called a loan formula, various places as well. Again, just keep in mind, if it says simple interest, this formula does not apply, but for all other loans, it will. So let's take a look at our first example. So on September 1st of 2023, I went and looked at current interest rates at CEFCU, a credit union here in Central Illinois. And so we're going to use those current rates for this example. So we are going to take out a $150,000 30-year mortgage at CEFCU. What is our monthly payment? And then how much interest will you pay over the life of the loan? So again, our formula is principal is our regular monthly payment times 1 minus 1 plus R over N to the negative NT power, all over R over N. Our principal in this case is the $150,000 we are borrowing. We are looking for our regular monthly payment. The interest rate for a 30-year loan can be found right there, so 7.125%, so 0.07125, and again, 12, 30-year loan. And as we have seen in similar formulas in the past, this quantity right here is again being multiplied by R. And then we have to figure out what number R is so that it equals $150,000. So as we start to do this calculation, again, no rounding will take place, but I am going to write a cut-off version, if you will, of this calculation. You'll get 148.4 and a whole bunch of other digits after that. Then in order to solve for R, we need to divide by 148.4 with all of those other digits. Again, I'm just shortcutting to not have to write quite as much. And we come up with a regular monthly payment, or in other words, your mortgage payment of $1,010.58 every month. That's your monthly payment. Now, as for how much interest you're going to pay over the life of the loan, remember, a mortgage means that you agree to pay back the money you borrowed, the $150,000, plus all of the interest. And if you don't, the bank can come take your house. So for the interest amount, we want to find the total that we paid on those monthly payments, and then we're going to subtract the principal to come up with the amount of interest. So the total that we're going to pay is $1,010.58 every month for 30 years. And then we're going to subtract the principal of $150,000, which I will write in here in a minute. Multiplying our monthly payment times the 12 months and the 30 years, we get $363,808.80. Subtracting our $150,000 in principal, we find that our interest, just the interest, is $213,808.80. And yes, that is very much the reality, that you can end up paying significantly more, in this case, more than 1.5 times as much money, well, actually about 1.5 times as much money in interest as you actually end up borrowing. So on this screen, again, you can see the calculations that were done in Desmos. So again, remembering that we have a capital R here representing our regular monthly payment. Once we get this number, 148.42, etc., we then need to take 150,000 divided by that number in order to come up with our monthly payment. All right, in example 2, we are again going to be using the mortgage rates that are current based on September of 2023. So the first thing we're going to do is calculate a down payment. So Maggie is buying a home for $190,000. When you put down a down payment, what that means is that you are paying a portion of the money that you're going to buy the house for right away. You're paying that up front. And by doing so, one is it gets you typically a better interest rate. 2, it helps you not have to pay PMI, which is a mortgage insurance that the bank takes out on you. It protects them in case you don't pay your mortgage, but you have to pay the premiums on those. And then 3, it also lets you borrow a lesser amount of money, which means you're paying less interest over time. So lots of reasons why you want to have a down payment, and 20% is like the golden amount. That is how much you want to put down to avoid having to pay that mortgage insurance. So if we take 190,000 and find 20% of that, we find that Maggie is going to have a down payment of $38,000. So again, that's what she gives them right away before she takes out her mortgage. She will then borrow the rest of the money needed in order to purchase her home. So the 190,000 minus the 38,000 means that she only has to borrow $152,000. Again, still a lot of money, but it's also a lot less than $190,000. Now, if Maggie chooses the 20-year mortgage, we're going to find her monthly payment. So the 20-year mortgage interest rate, just like the 30-year fixed rate, is 7.125%. So this problem is going to be similar. to example number 1, except our principal is a little different, $152,000. Not a plus, a 1 minus, sorry, 1 minus, 1 plus our interest rate, again, 7.125%, but this time only a 20-year mortgage, saving 10 years of payments. And again, just like we had before, we're going to go ahead and take this amount right in here, calculate that out. I am going to go ahead and take this exponent and I'm going to write that as a negative 240 in my calculation. And whenever we do that, again, we're going to end up with 152,000 is our times this number that we get when we do that calculation. That number is 127.7 with a lot of extra digits. And again, just as we did in the last problem, we're going to go ahead and divide by that number, the unrounded version. We get a regular monthly payment of $1,189.89. And again, here is the set of calculations carried out in Desmos, just to show the steps that were taken, how that was plugged in, and the division as well with all of the digits of accuracy. All right, so continuing this same example, calculate the amount of interest Maggie will pay. So interest, again, is the total that you pay minus the principal amount that is borrowed. So the total paid is $1,189.89 every month for 20 years, and she borrowed $152,000. Multiplying that together, we get $285,573.60. When we subtract the $152,000 that was borrowed, we find that Maggie paid $133,573.60 in interest. So if you compare that to the previous problem where the loan amount was roughly the same, $150,000, actually a little less, and for 30 years, remember that there was about $213,000 in interest paid. Even when borrowing $2,000 more, but cutting that term to a 20-year mortgage instead of a 30-year mortgage, you're saving about $80,000 in interest. So it can be significant savings, although you do have to pay more on your monthly payment. So there is a little bit of a trade-off. Now, what if we switch this to the 15-year mortgage, which the interest rate for the 15-year mortgage was a little lower at 6.875% interest. So again, setting up the same problem, but just changing the interest rate and the length of time. So 6.875 for a 15-year loan. And again, I'm just going to go in and make some quick edits to my Desmos is what I'll do. This one here becomes a negative 180. So I can change my exponent and I can change my interest rate. The number that we get, again, on the right-hand side that is being multiplied by R is 112.1 with a bunch of extra digits, dividing both sides by that number, unrounded, gives us a regular monthly payment of $1,355.62. For the amount of interest paid this time, again, exact same calculation that we've done. We want the total amount paid, so $1,355.62 every month for 15 years, minus the principal of $152,000. Total paid is $244,011.60 minus the principal of $152,000. means that for the 15-year loan, we're only paying $92,011.60 in interest. So again, notice the interest goes down by this time by another $40,000. Again, 5 years shorter, which is great. The trade-off is that your monthly payment is roughly $200 more. So it's something that you have to weigh the pros and cons. And again, just so you can check the steps done to carry out the calculation, there is the final set of calculations for the 15-year mortgage in Desmos.